Alright, welcome. This is the 8.3 Ready Set Goes topic. We're going to interpret the tables of values as an order pair, finding the f of x, then writing it as an order pair. Alright, here's the first one. The first x value, the domain was -2. So it's f of x equals 3x minus 2. Let x equals to -2 because that is the domain that we were given in. That's why it's function of -2. Plug in -2 in here for x. 3 times -2 is -6. -6 minus 2 gets you -8. So f of x is -8. In order pair, it would be -2, which is your x, comma, your y, or your f of x, as -8. Again, the process is repeated with -1. You plug in -1 here for x. 3 times -1 was -3 minus 2 would be -5, right? So the order pair here would be -1 comma -5. You wouldn't, this is a arithmetic sequence, and you see the common difference is 3. It's increasing by 3. The slope is 3. So you're adding 3 to each value here. So -8 plus 3 is -5. Plus 3 is -2. Plus 3 is 1. Plus 3 is 4. Okay, that's how you could also generate those values. Next one, this is x squared. This is a geometric sequence because of the exponent. Let x equals to -2. Here you go. I make that substitution. How do I get -2? -2 was given in the problem as the domain, or what the x value is. -2 squared. -2 times -2 is +4. There you go. For f of x, or f of -2 is 4. The order pair is -2 comma 4. If you plug in a -1 here, -1 times -1 is just +1. So the order pair is -1 comma 1. 0, 0. If you plug in 1, it's 1, 1. And if you plug in 2, it's 2 comma 4. This will look like a parabola if you graph it. Okay? It's all positive values because of the squared. The squared will always will tell you that it is always a positive value. Let's look at 3 now. X to the 5th power. This is also geometric in nature. Well, it's different. Okay, it's exponential, I mean. So, -2, 5 to the -2 power. Again, what do I do? Ooh, that does not look right. So, with this, first of all, I could show you the work here. The fact that is it's a negative exponent, right? You would have to bring it down. It becomes 5 to the 2nd power. You bring it down. When it was on the top, the numerator, it comes down to the denominator. That is how you get the exponent to be a positive value. 5 squared is 25. So when the exponent is -2 in this case, it's 1 over 25. If it's -1, you just bring it down, 1 over 5. If it's 1, just any 5 to the 0 power, anything to the 0 power is just 1. And this is 1 comma 5, and this is 2 comma 25. This is a exponentially increasing function. Let's go to the set part. Here I'm going to identify the quadrilateral. The first thing that I did is I labeled the I surrounded each side of the sides here by a triangle so I can find the distance, and I've noticed that all of them have the leg value of 4 and 5, 4 and 5, 4 and 5, 4 and 5. So I let A equals to 5, B equals to 4. It doesn't matter which one it is, right? Because they're both legs, you could switch them up. But I noticed that I define my C, or the hypotenuse, as the distance of the green line. So that would give me all the distances. I did the Pythagorean Theorem. A squared plus b squared equals to c squared. You can see the algebra here. I got the final answer as c equals to the square root of 41. The square root of 41 represents the green line here, which is the distance. I want to give you a side note. The reason, again, I could use the Pythagorean Theorem is because this makes a right triangle. How do I know it makes a right triangle? Because there is a vertical line and a horizontal line, and they always intersect at 90 degrees, hence making a right triangle if I have a third side. In this case, that's the third side here, makes the right triangle 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 here. I justified every single step with a logical progression. So all my green line here, they all have the same distance of the square root 41 because they all have this calculation because their A is 5, B equals to 4. Okay, so all these have the same length distance of square root 41. Now I need to find the slopes. So I got the slope for each one of this. This is change of y over change of x. So PQ is 405. QR is negative 5 over 4. RS, RS. So this is RS or SR. You read it from left to right, which is 4, 5. Okay, I can make this SR if that makes you feel better. PS, it's negative 5 over 4 because this is a negative slope, positive slope, negative slope here, positive slope here. The reason why I get the slope is I can check for perpendicular lines now. Remember, perpendicular line is m times the other slope gets you a negative 1. I saw that I got negative 1 so when I did all of them. So this is PQ times QR. So it's PQ times QR. That gets me negative 1. That's 90 degrees. QR times RS gets you 90 degrees. PS gets you 90 degrees. And PQ and PS gets you also 90 degrees because it's negative 1. So I saw that it gets me 90 degrees here. I got the distance, I got the angles. Now I can start answering the questions. Again, this is the hardest part. This is a calculation part, but this should be very straightforward. This is just the distance formula using Pythagorean Theorem. You all know how to compute slope, and this is the check to see if it's perpendicular. Right? This was all on your quiz. Right, so how do I know it's a right triangle? There's two particular theorems, but the diagonal one really doesn't work well for this one because we can't compute the diagonals, so we only use this one. First of all, you have to see if it's a quadrilateral, and you have to make sure it's a right angle. So yes, it is a quadrilateral because you have 4 congruent sides, okay, which were all square root 41. 4 congruent sides, and all of them are 90 degrees because you checked for a perpendicular right here. So you needed this calculation to prove that it's a quadrilateral. You needed the check for perpendicular to justify it's 90 degrees. Once you have those, you can say yes, it is a rectangle because it is a quadrilateral that has 4 congruent sides and all of the angles are right angles. B, is the figure on the right a rhombus? Is this a rhombus? We'll see. Again, I'm not going to use the diagonal. I didn't show anything parallel, so I'm not going to use this. I'm just going to use this. A quadrilateral is a rhombus if and only if it has 4 congruent sides. Do we get the 4 congruent sides? Yes, we did. Square root 41, square root 41, square root 41, square root 41. So yes, by the rhombus corollary, we would say this is a rhombus. Yes, it is a rhombus because the quadrilateral has 4 congruent sides. Last one. Is the figure a square? Right? There's only one corollary to the square. It is a square if a quadrilateral is a square if and only if it is a rhombus and a rectangle. We notice that it is a rhombus here. We just have to make sure that the angles here are 90 degrees. We showed that it is 90 degrees by doing the perpendicular check. M1 times M2 equals to negative 1 is the check. I saw that it all makes negative 1. Therefore, all these corners are 90 degrees. Hence, we would say it is a square because, again, it's a rhombus and it has 4 congruent sides and the angles are all right. Hence, it is a right squared. Next, here's the go part. Alright, here's the go part. So it asks you to find the perimeter. The perimeter is all the sides added up together, but I have to find each individual side. So I did the first calculation, 4 and 7. It's right here. I got the distance from 4 and 7, which is this right here, would be square root 65. That means this is also square root 65 because you see how the legs here is 4, 7. 2 and 6. 2 and 6 here. The diagonal here, the distance here is square root of 40. Square root of 40 here. So these two would be square root 40 and these two would be square root of 65. You add them together, square root 65 plus square root 65 plus square root 40 plus square root 40. Get you this. Do not add these up. These are different bases. You can add these two because they have the same base of 65. You could add these two because they have the same base of 65. Okay. 6 is the same calculation but a different object. I'm gonna be wasting your time if I just show it to you again because it's the same process. You would have to construct the triangles, find the distance, then add all the distance together. All right. Here, this is the exact answer. The book gives me a decimal answer. That's the approximate answer, but I bet you it's a square root. Alright, 7. I'm going to show the 7's calculation for you. 7, they're asking you to find the perimeter. The perimeter of a circle is just called the radius. It's called the circumference. The only things that you need to find the circumference is the radius. The radius here is 3. It is from the center to the outside of the circle, which is 3. Plug into the formula. C equals to 2 pi r. R is 3, so you plug in a 3 here. 2 times 3 is 6. Your exact answer would be circumference equals to 6 pi. The perimeter is also 6 pi. 8, you count it up, you should get around 18.63. 9 is 29.79. 10. First of all, again, if you ever want to find the radius or if you ever want to find the circumference of a circle or even the area, you have to find the radius. In this case, we can't just count it because it is diagonal, so we would have to apply the distance formula to get the radius here. Alright, because right here, the diagonal line here is the radius, and I could get that from using the Pythagorean Theorem because this forms a right triangle. A squared plus b squared equals c squared. I got the legs from just counting it. This is 3 for the horizontal, 2 for the vertical. Plugging it in, I get the r, which is the radius in this case, as square root of 13. You plug into the formula as r. 2 times square root of 13 is just 2 times square root of 13. Pi is left there. So again, this is for a full circle. This is not a full circle. This is half of a circle. They call this a semicircle. So you would have to divide this by 2. Divide that by 2. The 2 here disappears. So the circumference of this semicircle would be just square root 13 pi. That would be your exact answer. And there you go. Those are all your homework solutions for the 8.3 Ready, Set, Goes.